Now let's try to understand how the intersection of three planes is related with their normals. So as I said before, these days we have a lot of competitive examinations and multiple choice questions. There, we don't really have to solve simultaneous equations to get to the answer, right? We need to select the right one. And this knowledge which I'm sharing with you helps to do so, okay? Now the question here is, what can you conclude about the intersection of three planes if their normals satisfy n1 dot n2 cross n3 equals to 0? Or three planes if their normal satisfies that scalar triple product, this is also called scalar triple product, is not equal to 0, right? So that is the question. Now some of you may know about it, but it's kind of a very useful information which I'd like to share with you. So we are analyzing two situations about scalar triple product, right? Now, so there are two conditions. That is, we have normals, which is n1, n2, and n3. And if their scalar triple product is equal to 0, then what is the condition? And if their scalar triple product is not equal to 0, then what is the condition, right? Now, n1, n2, n3 could be in any order, it doesn't really matter, but always what you know is you have to do the cross product first, right? Otherwise, you'll get a scalar with dot product and then you can't do the next operation, right? So the cross product gives you a vector, so you have to do cross product first. It's never written in a bracket, but I'm showing you here that if those of you don't really get this one, then you have to understand a cross product gives you a vector, so vector dot vector is possible. But if you do the dot product first, you'll get a scalar. With scalar, we cannot do the cross product, right? So it is meaningless. Now let's come to the point. So first one is that the scalar triple product, this is also called scalar triple product, since it always returns a scalar value. The value could be 0 or could be something else, but not 0, right? So what does it mean? Now let's try to see when is it 0 and when is it not 0. Let's say there are two normals and two normals will form a plane, right? So let's say these are the two normals and they will always intersect. And now when you do their cross product, then what do you get? Their cross product will be normal to both, right? So their product will be normal to both. So what we have is, assume that the two normals form a plane which is plane of my paper. Then if I do cross product, then I will get something which is shooting out of the paper and it has to be normal to both of them, right? That is cross product definition, right? Now, if I have the third vector in the same plane, now think about it like this, that I have the third vector in the same plane. Now, if I have the third vector, let us say somewhere in this plane, then since this is perpendicular to the whole plane, it has to be perpendicular to this vector also. Now, if it is perpendicular, then the dot product will be 0. So that means in this case, all the three vectors n1, n2, n3 are coplanar, right? But if it is not equal to 0, that means they are not coplanar, right? That means they are not coplanar. So that is kind of one distinction between the two. So if scalar triple product is not equal to 0, that means the normals are not coplanar. But if it is equal to 0, that means they are coplanar, right? Now, if they are not coplanar, then how will they intersect? So here, the situation is very clear. They intersect at a point. So they intersect at a point. That is it, right? Always. So this intersection will be always at a point, right? It's not equal to, right? So I wrote it wrong place. So if this is not equal to 0, they intersect at a point, okay? Not here. So I wrote it the wrong place, right? If they're not coplanar, they intersect at a point. An excellent example for you is XYZ axis, correct? They intersect at a point. And you know all these three planes, they have normals which are not coplanar, correct? Now we have another video which will show you exactly by calculating that they do intersect at a point and scalar triple product is not 0 for it. So you can do that exercise on your own and check it out, correct? So this is kind of very important. If scalar triple product is not equal to 0, then they will intersect at a point. Boom. So you don't even have to do calculation, find the point, things like that. Multiple choice question, you can immediately get the answer, correct? Now here, when they are coplanar, then what happens? Then when they intersect, if they intersect at a point, right? So there could be two different conditions here also, right? That is whether the three planes do intersect or they don't intersect, right? So if they do intersect, they will intersect in a line, or they will not intersect, right? So will not intersect. They will not intersect, and if they intersect, they always intersect in a line, right? So if we have coplanar, we get that condition. They intersect in a line or they do not intersect. So in this case, we have two conditions, not one. So that means no intersection, and the other one is in a line, okay? So these are the two ways, and we'll take more videos here to get into details of this, when they're intersecting in the line and when they are not intersecting and having different kind of intersection, correct? Now, so we'll now see that. And there are so many other things which will help you figure out these answers, right? Example is that you can analyze whether the normals are scalar multiple or not, right? Whether the planes are parallel or not, right? Those things will help you to figure out where you should go, okay? So that is how we can help approaching an answer, or if not, eliminating others. So both ways it helps in multiple choice question. I hope you appreciate it. Thank you.